Sound good? Okay. Who wants to start? Josh. Number 3? Sure. So number 3 says, do the following relations represent y as a function of x? Explain your reasoning. So this is the problem for 3. If I look at this, right now as it's currently written, we've written it as representing x as a function of y, since the x is the part that's by itself. So the first thing that I would do is I would rewrite this to get the y by itself. So to do that, I would divide both sides by 2. And then we'll square root both sides. And remember, when we square root both sides of an equation like this, it generates a, plus or minus. Very good. And so now what I notice is because of this plus or minus, oftentimes when I pick a value of x, I'm going to get 2 separate values of y for that. So for example, if I pick x equals 2, I plug 2 in for x. 2 over 2 is just 1. The square root of 1 is 1. So I'm left with y equals plus or minus 1. What that tells me is I have the points 2, -1, and then 2, +1. Is that okay with how I've gotten to there? So would this be a function? No, right? Because we have an x coordinate that has more than one y coordinate. Does that feel okay there? And in terms of justification or explaining why, like that kind of work would be excellent in terms of a justification, where we've rewritten it with the y as the dependent, x as the independent variables, like the question or the context of the question implies, and then show why you're getting, provide a little bit of evidence there with a specific value of x that shows that, this gives me 1x with 2 y's. In general, anything that you picked that was greater than 0 would have worked. So there's nothing magic about x equals 2. There were lots and lots and lots of them. But 0 would have given you a problem, because you would have just gotten 1y for 0. And then the negatives wouldn't have even worked. So, but any positive would have been okay. So there's nothing magic about 2. It was just a convenient example. Others? Yes, Haley. 10? Sure. So 10's directions are different. We're asking you to find the domain of the function algebraically and then express our answer using interval notation. So the first thing I'm going to do is look at the function h of x. And there are 2 operations going on that we know about right now that can cause us a problem with our domains. So there's square roots and a division, right? If you're dividing and you have an x in the denominator, that can cause an issue, which is what we have here. And if you're square rooting something, that can cause an issue, which is what we have here. So we have both of these 2 things going on, right? So from a division perspective, I know that the square root of x can't give me 0, right? And then from the square root perspective, I know that x has to be greater than or equal to 0. Everybody's okay there? Okay. Well, if I squared both sides over here, I would just get that x cannot equal 0. And if I combine these 2 things together, if x can't equal 0 and x has to be greater than 0, or I'm sorry, greater than or equal to 0, that just means x has to be greater than 0 strictly, right? Everybody's okay with that idea? That if it can't equal 0, then it nixes the or equal to from the other inequality. And so now I just translate this into an interval. Oops. Is that okay, Haley? Yeah. Okay. Other questions from the homework? Again, if there's not any, that's fine. This is the first time we're doing this, and I'm just trying to show you kind of what the procedure looks like and what we're going to do, and just provide ample opportunity for anybody that wants to talk about anything that they might have seen that they weren't sure what to do with, a chance to do that. Krista? 12? Sure. So 12 also has a different set of instructions. So what 12 says, find the range of the given function, express your answer in interval notation. Notice that it doesn't, it's not asking you specifically how to find the range, so you're free to do that kind of using whatever method makes sense to you. You might have remembered from last year that this looks like the general form for a square root function. And you might have remembered from last year that for a square root function of this form, the domain and range look like this. Right? If you remembered that, that's enough right there for us to determine our range. If you didn't remember that, I'll cover how to do that in a second, okay? But just looking at this, we can see that the k is -2, and the leading coefficient is positive. So our range would just be -2 to positive infinity. Okay with that, Krista? And hopefully, at least, you may not have remembered this, but once we write it down, hopefully that looks familiar. Otherwise, what you could have done is you could have looked at the graph. And that's also a pretty reasonable way to go about doing this. I think that's, if I didn't remember this rule, that's what I would do. Because I think in general, using my eyes is easier than trying to think about these things algebraically. So I'll just graph this on my graphing calculator. And again, I don't remember what the last thing I graphed was, if my window would be appropriate or not. So instead of just hitting graph, I'm going to do zoom standard, because that makes sure that my window is that -10 to +10 window that you'd probably want to use. And so here's my graph. So I notice that it's increasing the whole way, right? That as I move from right to left along the curve, it's getting bigger. So that tells me it's going to positive infinity. That'll be the upper bound. And then I just want to identify the lowest point on this graph, which is right here. If I trace that over, that would be at -2 as the y coordinate. Everybody okay there? So at this point, I'm convinced that this is -2 to positive infinity. And because there's actually a point there at -2, I can put a bracket on it, right? Because there's a point that actually has -2 as its y coordinate. Does that feel okay, Krista? So we looked at how to do this a couple of different ways depending on what your level of comfort is, or how much previous stuff you remembered. And again, it's the first week of the semester. If you're like, I would not have remembered that, like I recognize it when you wrote it up there, but I would not have remembered it, that's fine. It's not a big deal. If you can look at the graph and figure it out, that's enough. And usually this stuff isn't so bad if you have a picture. that you can't figure that out. You know what I mean? Most of the stuff isn't so terribly complicated that if given a picture, you can't figure it out. Okay. Last chance for anyone else? Okay, cool. So I'm going to